So we're now in problem 5. This is in number theory. So a safe uses a code made from the value of this expression here, 2 to the 67 plus 3 to the 67 plus 5 to the 67. If the remainder of the expression when divided by 8 and 9 are x and y respectively, then find the value of 6x plus 7y. So essentially, ignoring the answer extraction, we're just tasked to find the remainder of this expression when divided by 8 and 9. So what do you guys think is the first step here? Oh, okay. Thank you, Ethan. Okay. So let's first go for modular 8, or let's first try to get the remainder when divided by 8. So this is mod 8. So firstly, note note that the first term there is 2 to the 67. We can already notice that since 8 is 2 cubed, we already know that 2 to the 67 is divisible by 8. So that has a remainder of 0. So 2 to the 67. So in mod notation, essentially this is 0 mod 8. So for those who are not familiar with modular arithmetic, this notation basically means that um, when you divide this number by this number, the remainder that you get is this. Okay. And I'll be using a similar notation for the others. Now let's go for 3 to the 67. This one isn't as obvious. So I'll present one method, which is if if you're not sure about this, then you can try to experiment with smaller exponents. So for example, if I try 3 to the 1, obviously the remainder is 3. If I try 3 squared, 3 times 3 is 9, which is 1 mod 8, so it's 1. And then when I multiply by 3 again, it goes back to 3. So essentially it cycles with period 2, right? And since 67 is odd, we can say that this has remainder 3 modulo 8. Another way of thinking about this is about the cycle is what Ethan Choi presented here in the chat, which is basically to write this one as 9 to the 33 times 3. And we already know that 9 is 1 mod 8, so this is gone. So it's 3. And then we do something similar, for 5 to the 67. If I try to list if I try to list down the first few exponents, then I get 5. Then 5 squared is 25, which is one more than a multiple of 3, 24. So it's 5, 1, 5, 1, and so on. And since 67 is odd, we get that this 5 mod 8. And therefore, the sum here is 0 plus 3 plus 5, which is 8, but 8 is a multiple of 8. So this entire expression is 0 mod 8. Okay. Now, just a note, you guys might notice that for both 3 and 5, the even terms here always have remainder 1. And this is a property that's consistent for everything that's relatively for all the betas relatively prime with 8. Note, some of you may know that n squared is always 1 mod 8, provided that, well, n is relatively prime to 8. Okay, cool. So now we do the same thing for mod 9. Can someone give me the remainders for each of the powers using a similar method? Okay, cool. So let's, oops, okay. So let's go for mod 9. I'll just erase all of this. Oops. Okay. So yeah, some of you are giving the correct answers. I'll just write everything here. Sorry for the delay. So for mod 8, we got 2 to the 67 plus 3 to the 67 plus 5 to the 67 is 0 mod 8. If we do a similar thing for mod 9, right, we get that 2 to the 67 loops 6 times. So as you guys said, or as Ethan Choi said again, you can think of it as 2 cubed is 8, which is negative 1 mod 9. And thus 2 to the 64 is 1 mod 9. Actually, if we try to list down the cycles here, we get 2, 4, 8, um, 7, and then 5, 5, and then 1. So just for completeness. And 67 is 1 mod 6. So we get that this is 2 mod 9. And 3 to the 67 is already divisible by 9 since 9 is 3 squared. So we write 0 mod 9. And then 5 to the 67, we can list cycles again. In fact, we also get that it's period 6. I'll just list it here for completeness. Okay, done. Yeah, okay. So in fact, it just goes backwards. And 67 is again 1 mod 6, so it's 5 mod 9. And thus we get that the entire expression here is 7 mod 9 because it's just 2 plus 0 plus 5. If you power the numbers, then adding them, yeah, the remainder stays the same if you add the remainders. So that's why just adding the 2, 0, and 5 here is a legal move. And so with the answer extraction, I think some of you already gave the answers. Yeah. So we substitute here x equals 0 and y equals 7. And thus we get that this is 6 times 0 plus 7 times 7, which is indeed 49. Questions?